Okay, this is another video from Easy Electric series, and today we want to talk about more advanced parameters in the VFD. And today let's talk about A083 S curve and see what exactly it means. So the A083 usually used whenever you want to actually run your motor more smoothly and you want to somehow get rid of that jerk that usually you have in the acceleration and deceleration. So the best example is elevator, right? Whenever you have elevator motor, so you try to somehow don't really feel that jerk that usually happen in the beginning, and especially on the stop of the elevator, you don't want to actually feel that. So let's to see what is that. So first let's to remind you the P39, which is acceleration time, time one. So usually we put that on the 10 seconds. So that means how long it takes your motor somehow start to accelerate from the zero frequency to the maximum frequency you adjusted. If you put 10, that means it's actually speed up, and in 10 seconds it's actually reached the frequency to zero to max, which is 50 hertz for my case. So if you take a look to the graph, so you plot the frequency versus time, usually that's a linear, right? If I put on the 10 seconds, so that means it's linearly, the frequency goes up, and this point is your max frequency, right? And in the 10 seconds, it's actually reached from zero to the max frequency that you have. As put that, it's actually run with the max frequency that you adjusted. So if you come and check the A083 S curve and put that 100%, what it means? It means actually it's give you a new acceleration time, which is it's more somehow is smooth. So if I put 100 on the 83, so the new acceleration time is 100% of what you have on P39, which for my case is 10 seconds. So should be 100 of the 10 second. So 100 of the 10 second is 10 plus what you have on P39, which is another 10. So technically you multiply 100%, whatever you put on 83, by what you have on P39. For my case, this term should be 10 plus whatever you already put on 39, which is 10. So for my case is 10 plus 10, which should be 20 seconds. So that means your new acceleration time is 20 seconds, as you see these red graph here, but this happen is more smoothly compared with what you have on P39. So that means in the beginning it's slowly it's go up, it's more actually soft or slow rate. So then here is actually a little fast rate to increase the frequency again close to the 20 second. It's actually more smooth, and finally you reach to the from 0 to 50 hertz, but you follow more soft pattern and soft rate of increase, which, as I mentioned, the most important application could be on the elevator whenever you don't want to really feel whenever the cabin is stop and also is start. So that means you have more soft start and stop. So let's go to our training set and see if we could actually have a demo for these P83. Okay, let's to actually test the S curve. So what I have here, the setting is 3 wire. So we put on the 3 wire setting. So now let's to check two things. Number one is P39. So let's to comes to here and check P39, which is the acceleration time. So my acceleration time is on 0, and the parameter for S curve is A083, right? So let's to go to A, and should be A83. So I go all the way up to 83. I click that. So I'm actually right now for the first one I put on 0. So that means the acceleration time is 10 seconds. There is no S curve. So let's actually run with this and see what's happened. So as you see, I'm going to push the start button. So see the how frequency change is very fast, is linear, right? So that means you see that speed linearly between 0 to 50. Even when if I take that off, see how fast it goes, and it's linear. So that means it's not the rate of the changing is not changing, right? So see the rate of the increase from 0 to 50 is exactly on the same rate, which is a linear. It's go all the way from 0 to 50. So now let's to stop it, and now let's to actually check the net again back here, and let's to change to a what's the parameter, A083, and this time I actually increase that to 100. So what it means, so it means my acceleration time 1/10 second, I change that to 100%. So technically should be 100% of 10, which is another 10 seconds. So a 10 plus 10 is 20. So that means now it should be actually move to from 0 frequency to the 50 max frequency that we have, but it is actually a curve. So that means it is more slow in beginning of the frequency, in the between max, close to the max, and mean is very aggressive to change rate, will change very fast, and again close to the 50 frequency should be again rate should be slowed down. Let's see if we could see that changing here. And I started as you see now it's very slow, right, compared with what we had before. Now see it's going to be faster. Now actually is very fast changing, and again close to 50 you will see that's again rate. See now rate is slowed down too, it's not fast as what we had in a few seconds ago. So it is 50. Same thing for the acceleration. Now see the rating is slow, now it's going very fast, again close to the 0, should be much actually slower, right? Let's actually check that again. So now again see slower in the beginning, so then your change of the change rate is go very up and faster, again close to the high frequency, the max, it should be actually again slow down, which is follow the S curve that we have that's happened in 20 seconds for our case. Same for actually the deceleration, more slow and lower frequency. Okay, so I hope you like this video. Thank you for watching.